How's it going, Tens? Today we're going on to problems involving right-angled triangles, working from slides 49 to 52 from the trigonometry PowerPoint. Okay, so the first question here is saying determine the length AB. So we want to find this length over here, AB. Now, if we have a look here, we've got two triangles. We've got this ACD triangle with 15 meters over here and 46 degrees. Then we have this ADB triangle and we have 32 degrees there. And we want to know that side. So if we look in this ADB triangle, we can't find this out straight away because we don't have a length of a side. But this triangle over here has a length. And if we can find the length of AD using trig, then we can find that length over there. So with these type of problems, what I do is I break it down into the two triangles. So this triangle over here will be this bottom one, ADC, where that is 90, this is 46, and this is 15 meters. This one will be the top one, ABD, 32, and this is the side that we want to find. Okay, and as you can see, the link between these two triangles is this AD side. So if I can find the length AD in this triangle, because I have more information in this triangle to find it, then I've got that length over there, then I can find that one. So that's how I'm going to do this. So I'm going to say in triangle ADC, from this angle over here, this is your hypotenuse, this is your adjacent, and this is your opposite. Okay. Now we want to find this adjacent side over here. So we're looking with the trig for a trig function that has that combination of AH, adjacent hypotenuse. And if you do your little rhyme, it's silly old hens, cackle and heckle. So it is cos. So we know that AD over AC will be equal to cos 46. Because this is A over H. Okay, I'm going to get the AD on its own just by multiplying up by AC. So we get AD is equal to AC multiplied by cos 46. We know what AC is, it's 15. So AD is equal to 15 times cos 46. Get your calculator. And then we just say 15 times cos 46. And what we're going to do is we're going to round this off to 2 decimal places. Okay, so this would be 10.42. So AD is equal to 10.42 meters. Okay, so now we know that this is 10.42. That means that this one here is 10.42 meters because it's the same thing, AD. Okay, now I'm going to work in this triangle here. In triangle ABD, I'm going to work with the triangle, with the angle that we know. So this here would be your hypotenuse, opposite, and adjacent. And we are looking for a trig function that has the combination A and H. So, silly old hens, cackle and heckle. So it is cos. So we know that in this case here, we're going to get cos 32 degrees is equal to AD over AB. Now, grade 10, you're probably saying, but then why with this one did I put the AD over AC equals cos first, and over here I put the cos first, and then the AD AB? It doesn't really make a difference, grade 10s. You can do it either way, all right? And that is why I'm just showing you I can do it this way or I can do it this way. The result will be the same, okay? We want to get this AB on its own, so I'm going to multiply up by AB times cos 32 equals AD. Now I'm going to divide by the cos 32 to get the AB on its own. So we get AB is equal to AD over cos 32. I know what AD is. It's 10.42. So we get AB is equal to 10.42 over cos 32. Put that on our calculator. 10.42 over cos 32. And round that off to 2 decimal places. So we get 12.29. So AB is equal to 12.29 meters. And that's what they wanted. Okay. Moving on to the next example. Okay, example 2. Example 2 is saying 2 flagpoles, which would be AB and DC, those are your flagpoles, are 6 meters apart. One flagpole is 15 meters high and the other is 8 meters high. 2 ropes connect the top of each pole to the foot of the other. So here's the top of the one pole, there's a rope going to the foot of the other flagpole, and then likewise for this side. We've got the top of the flagpole, there's a rope attached there, and it's tied off to the bottom of this flagpole over here. Question A is, what angle does each rope make to the ground? So in other words, we need to find out what alpha is and what theta is. So again, we've got 2 triangles here. We've got this ABC triangle, and we've got this DCB triangle. I break the problem down into its 2 triangles. So we have this ABC triangle and this DCB triangle with its information in. Okay, now this BC is the same for both triangles, so they'll both be 6. Okay, so let's have a look in this triangle over here. So in triangle ABC, from the angle that we want, okay, I'm going to fill in my adjacent, hypotenuse, and opposite. So this is your hypotenuse, adjacent, opposite. Okay, so we're looking for a trig function that has the combination. I'm looking at the information that we have. We have this side and this side. So we're looking for something that has an O and an A. So silly old hens cackle and hackle till old age. So it must be tan. So we know that tan theta will be equal to AB over BC. Fill in our information. So tan theta is equal to AB is 15 over BC is 6. So theta is equal to, now remember grade 10s, to find the angle, you go shift the trig function and then the number on the side. So we're going to go shift tan 15 over 6. And we are going to round this off to 1 decimal place. So to 1 decimal, that will be 68.2. So theta is 68.2 degrees. Right, let's do the same for this one over here. In triangle DCB, from the angle, I'm going to fill in my opposite, adjacent, and hypotenuse. So this is 90 degrees. This is your hypotenuse, adjacent, opposite. Okay, so we're looking for something that has that O and A combination, because those are the sides that we have, and it will be tan, because it's silly old hands cackle and hackle till old age. So tan alpha is equal to DC over BC. fill in our information. DC is 8, BC is 6. Remember, we go shift tan to get the angle, shift tan, and we've got 8/6. And we round this off to 1 decimal place, so it's 53.1. Alpha is equal to 53.1 degrees. Okay. Question B, determine the length of each rope. So we want to find, if I work in this triangle over here, we want to find that side, and we want to find that side for this triangle. So I'm going to try and fit this on the same page because we have all the information here. So we want to find this one here. Now, it doesn't really make a difference which one you use, either the A or the O, okay? I'm just going to use the O, grade 10. So I'm looking for a trig function that has the combination OH. So, silly old hens. So we know it's going to be sine of this angle. We know what that angle is. So we know that sine 68.2 will be equal to AB over AC. Remember, we want to find the AC, so I'm going to get that on its own. So it's AC multiplied up by the AC times sine 68.2 equals AB. Divide by sine 68.2 and we get AC is equal to AB over sine 68.2. We know what AB is, it's 15. So we get AC is equal to 15 over sine 68.2. Put that on the calculator. 15 over sine 68.2. Round it off to 1 decimal place and we get 16.2. So AC is equal to 16.2, and this is meters. Okay. Moving on to the next one. So we have to find the length of this rope, which is DB. And again, I'm just going to use this O. All right, so we're looking for a trig function that has the OH, which is going to be sine. Silly old hens. So for this one here, we know that sine, now we know what alpha is, it's 53.1, will be equal to, O is DC, or CD, over BD. Remember, we want to find the BD, so I'm going to multiply up by BD, equals CD, divide through by the sine 53.1, and we get BD is equal to CD over sine 53.1. We know what CD is, it's 8, so we get BD is equal to 8 over sine 53.1. Put that on our calculator. So 8 over sine 53.1, and to 1 decimal place we get BD is equal to 10 meters. So we've got the length of both the ropes. Okay, grade 10s. There is a third part to this question which I'm not going to go through with you. It is a bit advanced. If you would like to see the solution for it, we can go through it. I don't mind. But I think it's a little bit too advanced for now. Okay. Also, just having a look at this, what we could have also used, grade 10s, is we could have used Pythag. Because you see, we've got that side, we're missing that side, so we could have used Pythagoras. Likewise for this one. But either or, they would give you the same answer. Okay. So, what I would like you guys to do is exercise 15.1, numbers 1, 3, 5, 6, and 7 for me, please. Thank you.